Hello, and welcome to 123 AP Physics. This week we're going to be covering forces and dynamics, otherwise known as the why of motion. Kinematics is the how, forces and dynamics form the why. So why are things moving? Why are they stopping? Why are we getting this acceleration? So let's begin. What is a force? It's usually defined as a push or a pull. It causes a change in the object's motion. That's pretty key. It's a vector, and it's measured in newtons. So, inertia. Inertia is the object's natural resistance to motion. Heavier objects are heavier because they have more inertia. So, an object with a larger inertia takes more force to produce the same acceleration. So, that's where we get Newton's second law. Newton's second law says that the force divided by the object's inertia is equal to the acceleration. Or if you rearrange it, the force is equal to the inertia times the acceleration. And inertia is also called mass, and it's measured in kilograms. So you can say that the force F equals the mass M times the acceleration A, or F equals ma. And that's going to be the formula that you hear the most often in dynamics. F equals ma. Sometimes they put a capital sigma, which means sum. So the sum of the forces is equal to the mass times the acceleration. But if there's just one force, then it's just F equals ma. So Newton's laws. The first law says that forces are responsible for any change in an object's motion. I paraphrase that a lot. It's actually goes along the lines of an object at rest stays at rest until and an object in motion stays in motion until an outside force acts upon it, but it's the same meaning. The second law, as I already said, is F equals ma, and the third is for every action there is equal and opposite reaction. So for there to be a force on an object, then the object exerts the same force and magnitude but opposite in direction upon the object that's exerting the original force. It sounds weird, but you can ignore that for the most part until we get into collisions and gravity and electrostatics. Those are going to be the three where those actually matter. So that third law, you can mostly ignore it for now. Okay, so a free body diagram is a way of showing all the forces that act upon an object. So every force is labeled, usually with like an F and then a subscript for whatever the force is. So the force of gravity, the normal force, which is just Fn, the force of friction, Ff, or sometimes a cursive F. Every force is labeled, and they have relative length, so that the largest force is the longest, because they're all vectors, so the length matters. The forces are drawn from the center of mass. Usually you can just draw it as a dot in dynamics, because if we just imagine all the forces acting upon the center of mass, we're allowed to do that, and it makes things a lot easier. So a freely falling body, there's a little dot, and there's the force of gravity. Freely falling means that only the force of gravity is acting upon it, so that's why you only see the force of gravity. So how to find the force of gravity? So this is F equals ma. We know the acceleration is always going to be 9.80. If we know the mass of the object, we just use F equals ma. And the force of gravity is also called the weight. Although a scale, it actually measures your normal force, not your weight. So you'll find out what the normal force is in a minute. Actually, right now. So the normal force is the reason why we don't fall into the earth. The ground pushes back on us, and that's called the normal force. It's always perpendicular to whatever surface you're on, and it's usually equal to mg, but not always. Like if you're undergoing an upwards or downwards acceleration, then it isn't. The friction is based upon the normal force, and it's the normal force times the coefficient of friction for the material. So that's this little thing down here. It's called a mu. That's the reason that you have friction. It's the normal force times the coefficient of friction. And so different materials have different coefficients, and there's a different coefficient if you're standing still or moving. and moving it's lower because when you're still, your atoms have weak interactions with the ground, and so you have to break those weak interactions to begin the process of movement. But when you're moving, you don't have those weak bonds, so the friction's less. Usually we'll be working with kinetic friction, but occasionally you'll have a problem that's like, what is the minimum coefficient of friction needed to not move, and then you'd use the static friction. You'd be looking for static instead of kinetic. So springs. Springs are you'll see them pretty often. They're pretty nice examples of simple harmonic motion and stuff. So the restoring force is, which is what we're focusing on this lesson, is just the force. The restoring force is F is equal to the negative, is a negative times the K times X. K is a spring constant of the spring, so it's like how hard is it to stretch out this spring. It's measured in newtons per meter, and X is the displacement. And then the negative, remember with vectors, how the negatives just mean opposite direction. So since this is a force, it's a vector, so the negative means it's opposite in the direction of the displacement. Inclined planes, you're also going to see this a lot in forces. On an inclined plane, if you take normal x and y axes and rotate them so that the inclined plane angle of inclination is now the x-axis, so if the plane's inclined 10 degrees, the x-axis is now inclined 10 degrees relative to before. Gravity now has a horizontal component. And so that force of gravity parallel to the plane, so the horizontal component, is equal to mg sine theta, and the force of gravity perpendicular to the plane is equal to mg cosine theta. And so the normal force would now be equal to mg cosine theta instead of just mg. On inclined planes, mg sine theta, sine and cosine switch. So normally cosine is the parallel, but in this case it's perpendicular. And that's because if you were to construct triangles, which is how all of this got started, people constructed a whole bunch of triangles and realized that, hey, it's the same thing every time. It's always the mass times gravity times the sine of theta for the length of the parallel vector. And so then we can just say, oh, it's just mg sine theta instead of actually having to construct the triangles. But if you were to draw the triangles and use law of cosines and law of sines and write triangle properties, you would be able to see that the length of the parallel and perpendicular vectors are equal to the mass times gravity times the sine or cosine of theta, because the angle is measured from the vertical and not the horizontal. So if you use the coincident rule, so like the 90 minus theta is equal to the other one, sine or cosine, you're using that, and so that's why you just flip the sine or flip the cosine. But alright, back on track, we're going to start working on some problems. So a block has a force of 20 newtons to slow it from 10 meters per second to 5 meters per second in 2 seconds. So what is the mass of the block? So we have the force, we can find the acceleration, right? So it's 10 minus 5, so it's 5 meters per second over 2 seconds, so it's 2.5 meters per second squared. And since we know F and we know A, we just solve for M, so F over A is equal to 8 kilograms. So there you go, pretty simple problem. The next problem, a 5 kilogram block starting from rest and undergoing a constant acceleration covers 100 meters in 20 seconds. Find the force acting on the block. So this one, it's going to be, and we're going to have to use our kinematics properties. We know initial, we know displacement, we know time, so, and we know mass, and we want to find acceleration, and from that we want to find force. So we're going to find the force, so x equals v naught t plus 1/2 at squared. V naught t cancels, so 100 meters times by 2 divided by 400 seconds, because the 20 squared is equal to A. So A is 0.5 meters per second squared, and then 0.5 meters per second squared times by 5 kilograms equals 2.5 newtons. Pretty simple problem again, just solving for what A is, and then F equals ma. A force has components with magnitudes and direction of 70 newtons in the x direction and 25 newtons in the y direction. What is the direction and magnitude of the original force? So this one is just, it's actually a vector problem. It says it's a force, but it's a vector because forces are vectors. So we just used Pythagorean theorem, and so we get that the force is 74.3 newtons. Tan inverse would tell us that the degree is 19.7 degrees from the horizontal. Okay, moving on. An object is moving across a horizontal table with friction. Draw a free body diagram for it. So this is our object right here. So the first thing you always do is draw gravity. So we draw force of gravity and label it. And since it's not accelerating in the y direction, we have the normal force to oppose it. It's the same length because it's the same magnitude. There's the normal force, and there is friction. And so friction, it's always going to be smaller than the normal force because you can never have a coefficient of friction greater than 1. It violates laws of physics. So we draw friction and label it, and it's smaller than the normal force. So, alright, problem number 5. A person is on a scale in an elevator. If the normal weight of the person is 980 newtons and the acceleration of the elevator is 5 meters per second squared, what is the weight of the person when the person is going up or going down? Okay, so here we need to find the mass of the person. So that's m is equal to 980 newtons over 9.80 meters per second squared is equal to 100 kilograms. So the person's 100 kilograms. I think that's somewhere around 180 pounds about. So, okay. Just on a side note. Okay, so F equals ma. So we could, right, so we know the acceleration, we know the mass of the person, we know one of the force, but for the person to be accelerating upwards, the normal force has to be greater than the force of gravity to produce that upwards acceleration. So this is where that sigma I was talking about, how I don't write it usually, but it is there. It's the sum of the forces. So F equals ma. So it's this the two forces in the y direction are the normal force and the force of gravity, and we know the mass and we know the acceleration. So, and because we know the force of gravity is 980 newtons, right there, because that's your weight, is the force of gravity acting upon you, we can move that over and say that the normal force is equal to 500 newtons plus 980 newtons is equal to 1480 newtons when going up. So if this person was on a scale, they'd find out that they were 500 newtons heavier when they were going upwards. So if you wanted to lose some weight fast, you just go downwards in an elevator, and hey, you just lost 500. You just lost your mass times the acceleration of the elevator in no time at all. That's a pretty good way to lose some weight. Okay, so solving for going downwards, we'd say the same thing, except now the acceleration is negative 5 meters per second, so you get negative 500 plus 980 newtons, and so the weight is now 480 newtons when going down. And that makes sense because when you think about it, when you're going upwards, you're overcoming the entire force of gravity and then some more, so it makes sense that you weigh more. And when you're going downwards, if the elevator moved at 9.8 meters per second squared, it'd be freely falling body, and so you'd be weightless. But since it's only going at 5, you only have a small portion of your weight, a little bit less than half, to just stop anything more than that 5. So these numbers make sense, and you should always be checking the solutions you're getting out of these problems to make sure that when you think about it, does this make sense? And if it doesn't, you either messed up somewhere, or the problem is just a bad problem. Sometimes that happens, and you'll be getting just wonky numbers. But that doesn't happen too often, and I've worked through these problems myself to make sure that doesn't happen. Okay, moving on. Two blocks are suspended from a frictionless, massless pulley. Block A has mass 5 kilograms and block B has mass 3 kilograms. What is the acceleration of the system? Okay, so we're asking for the acceleration of the system. So if you were to draw free body diagrams for these two blocks, you'd see that they both have, because ropes exert tension. So like if you suspend something from a rope, it exerts a force, and that force is just called tension. It's just convention. They just say the force exerted by a rope is called tension, and then every rope can only have one tension. And so these are connected by a rope that passes through a pulley. So, but it's a frictionless, massless pulley, so the rope has only one tension. Okay, so block A has mass 5 kilograms and block B has mass 3 kilograms. So we're asking for the acceleration of the system, so we need the mass of the system, and then all the forces in the system. The tension is going to cancel because it's acting in opposite directions for each block. So we can just ignore the tension and say that the force of gravity of block A minus the force of gravity of block B is equal to the mass of the system, so the two masses times the acceleration of the system. So if we factor out a g, it's g times by m1 minus m2 over m1 plus m2 is equal to a. And this is a nice little shortcut formula. It's always going to work for any system. It's where all the blocks are just hanging from one pulley, and it's a frictionless, massless pulley. The acceleration of the system is always going to be the force of gravity times by the weight of any blocks that gravity is acting upon, and normal force is not opposing, divided by the mass of the entire system, every single block. So we plug in what we know, which is everything, and solve for A, and so the acceleration is 2.45 meters per second squared. Okay, moving on. An 80 kilogram block is suspended from two ropes, each inclined at an angle of 45 degrees from the horizontal. What is the magnitude of the tension in each rope? This is another really common problem. It's the hanging box problem, you might see it called. The box is hanging from two ropes. Sometimes they're inclined at different angles, sometimes they're not. And you might be looking at this and saying, there's not enough information to solve it. You don't know the tension of either of the two ropes. If you did, it'd be a simple problem. But you don't know the tension of the two ropes. Well, that's where systems of equations come in. Remember last lesson when I said that whenever you don't have enough information to solve a problem, you're probably expected to solve it with a system of equations if they want an actual numerical answer. So in this case, they do want a numerical answer, so we have to think. So we know every force, we have our y formula written, and so we could write a formula for the x direction because the tension isn't at 90 degrees, so there is an x component, and the x components are going to be perfectly opposite because there's no movement in the x direction or in the y direction, so the sum of the forces is 0. So that's going to be a nice little shortcut. So the sum of the forces in the x direction is equal to 0. So it's equal to the first tension times the cosine of 45 degrees minus the second tension times the cosine of 45 degrees. If we solve for T2, we could say that T1 equals T2 because the cosines would cancel, and so it's just T1 equals T2. That will be helpful because now we only have to solve for 1. So now we look at our forces in the y direction. We say that sum of the forces in the y direction is equal to T1 sine of 45 degrees plus T2 sine of 45 degrees minus 80 kilograms times 9.80 meters per second squared, because that's the force of gravity acting upon the box. So since we know T1 equals T2, it's just 2T sine of 45 degrees is equal to 80 times 9.80, and so the sine of 45 degrees is radical 2 over 2, so it's just radical 2 times the tension is equal to 784 newtons, which is what you get if you multiply 80 by 9.8. Dividing by radical 2, you get that the tension is equal to 554.4 newtons, and so the second tension would be the same. Okay, next problem. A spring with constant 500 newtons per meter is stretched 45 centimeters in the negative x direction. What is the restoring force? Okay, so this is just using that formula that we learned earlier. F equals negative k of x. So F equals negative k of x, plug in the restoring force and plug in the displacement. So it's negative times 5,000 newtons per meter times by 0.45 meters. This is the force is equal to negative 2,250 newtons. Okay, next problem. A block is resting on a plane inclined 10 degrees with respect to the horizontal. What is the minimum coefficient of friction needed to hold the block in place? Okay, so we're going to be, friction would be acting in the x direction in this case. So we're going to be looking at all the forces that are acting in the x direction. So the only two forces are gravity and friction itself. So, and since we don't want the block to move, that's going to be equal to 0. So mg sine theta minus mu mg cosine theta is equal to 0. Because this mg cosine theta is the normal force. So we could cancel out mass, we can cancel out gravity. We could say that g sine theta is equal to mu cosine theta. Or solving for mu, sine theta over cosine theta is equal to mu, because m and g both canceled, remember? So it's just sine over cosine, which is equal, so the sine of 10 degrees over the cosine of 10 degrees is approximately 1.176. So this is a unitless quantity. Mu is unitless. There's no units associated with it, because the normal force is already in newtons. So you can't multiply it by any units, otherwise you wouldn't end up with newtons. So that, just a little thing to remember, mu doesn't have units. Okay, so here's an FRQ. I got this one from the 2015 AP Physics exam. If you search College Board AP Physics exam FRQs, you can find loads of them. There's only 2015 and 2016 for Physics 1. But if you look at Physics B, it's Physics 1 and Physics 2 nowadays. Physics B was all of it. So you have to search through them to find the ones that relate to Physics 1, but there's some good ones there too. And it's always helpful to work on more FRQs. So two pulleys are connected by a string of negligible mass that passes over massless pulleys, so I didn't draw them here, but they're there, that turn with negligible friction as shown in the figure above. It's this figure. The mass of M2 is greater than the mass of M1. The blocks are released from rest. So draw 3 body diagrams showing and labeling the forces, not components, exerted on each block. Draw the relative length of all vectors to reflect the relative magnitudes of all the forces. Derive the magnitude of the acceleration of block 2. Express your answer in terms of M1, M2, and G. And block 3 is added to the system as shown below. There is no friction between block 3 and the table. And they want you to indicate whether the magnitude of the acceleration of block 2 is now larger, smaller, or the same as in the original 2-block system. And explain how you arrived at your answer. So pause the video, start working through it now. I'm going to give you guys a few seconds. Okay, I'm going to begin working through the problem now. So the first thing to do is draw your blocks and draw the forces emanating from them. So there's gravity for the first one, there's tension, and there's the second force of gravity. The second force of gravity is larger than any of the others, which makes sense because the block's heavier than the others. These two tensions are the same length, although they don't look it, but that's just because of the block. And then this force of gravity is the smallest, of course, because this block would be accelerating upwards, so it has to be smaller than tension. Okay, moving on, part B. If you go back to this problem that we were working on, all the way back to this one, problem number 6, it's the exact same problem. This little shortcut formula is going to be the formula we're trying to figure out. So if you don't know this formula by heart, or you forgot it, you can derive it from the sum of the forces. So it's just G times by M2 minus M1 divided by M2 plus M1 is equal to A. That's going to be the case for every two-part pulley. And sometimes if the three-part pulley, there's no extra force of gravity, but there is extra mass. So since you're dividing by more mass, the acceleration of the system is less. All that makes sense physically. Pretty simple problem. Next week we're going to be studying energy, so tune in for learning more about kinetic and potential energies. Till then, see ya.